Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback from you guys, the quality of video as well as audio. Is it perfect or not? If it is perfect, just write perfect over the comment box and then we'll move ahead. So I'm just watching over the comment box, and if the quality of audio and video is perfect, you can just write perfect over there. Yes. Now let me discuss what was the agenda behind the last class. In last class, first time I introduced the topic called probability. There we talked about the little bit theoretical part about the probability, few of the important words which we would be using again and again. There we talked about the fair trial as well as fair experiment, and the fair experiment was also called as a equiprobable events or equiprobable experiment. There in case of probability, basically yesterday's class was more or less concentrated over the concept of the permutation as well as combination. If you guys would be able to recall what was the permutation? The permutation, if we deal with a certain case, or the permutation deals with a certain case in which we try to calculate in how many ways the R number of items can be selected, collected, withdrawn from n number of items, keeping order in our mind. That means if we are changing the orders of the selected item, definitely they would be called as the different events. And similarly, when we were dealing with the combination, there we talked about the NCR. In case of NCR, we were just focused about the number of ways the R items can be selected, collected, withdrawal out of n number of items, and there the order does not make any sense. At very starting segment, around 7 to 8 number of problems, I just took based on the concept of the permutation and combination, how many ways, the number of 10 MPs can be selected out of 284 number of MPs as the BJP got elected, and similarly out of 10 number of ICC cricket playing nations, 2 nations can be chosen as a finalist. So around 10 number of questions I discussed in the last class. But the permutation and combination was straight away used in case of probability, and there what I did, I had a box, I had the 3 different colors of balls, and always I was choosing the 2 balls out of probably 7 or 8 number of balls. Probably the 7 number of balls were there. And even while choosing, the complete problem got classified in 3 different patterns. The first pattern, both of the balls was chosen at once or together. The second classification, both balls was chosen in succession or one after another, but without replacement. That means I took out 1 ball and after that I just threw it out, and again I am picking 1 ball next. The third case was one after another with replacement. What does it mean of it? The name itself is self-explanatory. You are going to withdraw 1 ball, you are just checking the color of that ball, you are picking that ball again back into the bag, and after mixing you are again picking 1 ball. So as far as the withdrawal is concerned, the withdrawal can have the 3 different pattern. The first together, there the 2 balls was brought out together, even it could be the 3 balls brought out together, maybe 4 balls are brought out together. Similarly, the second could be in succession of one after another, and even one after another can have the 2 classification, without replacement as well as with replacement. Is that part clear? So anyways, more or less almost the concept of the permutation as well as combination was cleared in the last video. Now what I am going to do, in starting 4 or 5 number of problems, I am going to take the problems which are based on probability and straight away comes from the concept of permutation and combination. Is that part clear? So let me focus over the first question, and you can see over the board, the problem have come in GATE Electrical, year of 2004, and the problem was framed by IIT Delhi. So let me visualize each and individual word, and at last we'll try to get the answer out of this. From a pack of regular playing card, 2 cards are drawn at random. What is the probability that both card will be king if the card is not replaced? Last 3 or 4 words are very important. If the card is not replaced, what does it mean of it? That means the 2 cards has been withdrawn in succession, and if the first card has been taken out, that has not been replaced back. Is that part clear? So can you tell me what would be the solution of this particular question? This particular question. I want the answer from each one of you. I want the answer from each one of you. Yesterday, day before yesterday, I was showing the exact or the correct answer over here. Deliberately, I have hidden it so that I would be getting the actual answer which you are getting while solving it. Can you tell me what's going to be the best most answer? What's going to be the best most answer? What's going to be best most answer? I want the input from each one of you, because if you guys could saw my last video, definitely you can relate or you can correlate the concept which was taught in the last class, and you can easily smash this problem. Now, at very starting, each and everyone should have a clear-cut understanding. Whenever we talk about a pack of card, one pack of card, or one deck of card, may I know how many number of card one deck possesses? 52 number of card one deck possesses. Out of 52 number of cards, 26 number of cards are red in color, and remaining 26 number of cards are black in color. You need to have this classification in your memory if you want to crack the problem related to the deck of card or pack of card, and the problem used to come from this domain. Is that part clear? Yes. Now, even the complete card has been further bifurcated in terms of their suits. So now you can have the second classification. Even the 52 number of cards are bifurcated in terms of their suits. How many suits they have? The 4 number of suits they have. The first suit goes for diamond. The color is red. Diamond. The next is heart. The color is again red. Next is, see, black I cannot use over the blackboard, so I am using the white pen. The next is spade, and similarly the last is club. The club is sort of this. Last is club. Now the 52 number of cards are equally distributed in terms of diamond, heart, spade and club. Keep in mind that means the 52 would get divided by 4. So 13 cards would be the cards from diamond, heart, spade as well as club. Is that part clear? I'll write one thing once again. This diamond and heart comes under the classification of red card, and similarly spade and club comes under the classification of black card. Not only that, even you can go ahead with few more important facts. Number of face card, if you talk, face card. The each suit, either it's a diamond, either it's a heart, either it's a spade, either it's a club, they all carry 3 number of face card in each suit. It's a jack, queen and king. It's also called as a joker, queen and king. So may I know how many number of face card in total you have? The 3 will come from diamond, the 3 will come from heart, 3 would come from spade as well as 3 would come from club. Together you have got the total 12 number of face card. An individual suit have got the 3 number of face card. 3 number of face cards. Is that part clear? So face card in total you can say 12. Similarly, one more important point. How many number of ace cards you have? the total 4 number of ace cards you have, which will fall in either of the suits. The 4 number of face cards you have in total number of face cards which you have is 4. So I have seen many of the time students just get stuck because they do not have the clear-cut understanding about the structure of a deck of cards. Although they must be or they may be acquainted with the concept of the probability, but until and unless you do not have a little bit idea about the structure of the playing card or deck of playing card, you may not be able to smash the problem. You may not be able to smash this problem. Is that part clear? Have you written this clearly? Each and every point has to go into your copy. And one confusion used to be there in most of the student. Ace card ace card is not counted under the face card. Why? Because once you'll see the ace card, nowhere the face is marked over that card. So I have seen in rare of the rarest cases, in few of the books, even they include face card or they include ace card inside the face card, which we need not to do. That is what I am saying. As far as the face card is concerned, the card which contains face, that it starts from jack, goes to queen and completes at king. Now, come to this problem. May I know what's the best most answer? So now I have started getting the answer. The Govind Kumar have given answer as D. Vaishnavi Dhuria has given answer as D. Pradeep R have given answer as D. No, 12. Anyways, there is no answer as such 12, and as far as the concept of probability is concerned, the probability will always be in between 0 to 1, including 0 as well as including 1. Now, just focus over this point. From a pack of regular playing card, may I know how many number of cards you have? In a regular playing card, you will have 52 number of cards. See, nowhere it is being written, so until and unless you do not have the fair idea about this structure, you may get trapped in this problem itself. Next, 2 cards are drawn at random. Now the problem comes, how? Together, one after another without replacement, one after another with replacement. It has been clearly written without replacement. Now, what is the probability that both card will be king? Both card would be king. That means the first card which has been withdrawn has to be king, and similarly the second card which has been withdrawn has to be king. Or you can write probability for the withdrawal of the king in first trial, and for and definitely the multiplication will take place. Probability for the withdrawal of king when the first card already which was withdrawn out or withdrew out was king. So it's gonna be P of k dot of P of k by k. May I know what's gonna be P of k? Out of 52 number of card, you are going to select a card which is king. May I know how many number of kings you have? In 4 suits, each will have 1 king. So it's gonna be 4c1 as well as 52c1. Now, initially you can see you have total 52 number of card, and among 52 number of card you had 4 number of king. But without replacement, if one card has been taken out and that card was king, so may I know what would be the structure of new pack? The king would be 3 in count, and similarly total number of card would become 51. So again, I want to have a king out of how many number of cards? 51. Whereas only 3 king have been left out. Is that part clear? So now, may I know what was the 4c1, 3c1, 52c1, 51c1? I know many of these students are going to spend unnecessarily time over this just to calculate 4c1. They'll have a soft calculator over the screen and they'll feed 4, then c, then 1. Hell amount of time you are going to consume. That is why in yesterday's class, exactly one expression was presented in front of you. What it was? nc1 is simply equals to of n. And the same structure is coming over here as well as here. So may I know what would be the 4c1? The 4c1 would be simply equals to a 4 into it would become 3, and similarly here it would become 52, 51. 52, 51. Is that part clear? So let me divide few of them. Here it would become 4 1 ja, 4 3 ja, 4 3 ja. So anyways, try to get the answer out of this. Try to get the answer out of this. D, obviously. The answer is gonna be D. You can simply find out. I'll repeat it again. So at very first, you had the 4 number of king and you wanted to select one out of them. Out of 52, 1, and again now it became 3C1 and similarly 51C1. And once you'll get the answer is simply gonna be D. Answer is simply gonna be D. This problem have appeared in GATE Electrical year of 2004. The problem was framed by IIT Delhi. So probably this part must be clear to all of us. And if it is clear, just write clear and then we'll move ahead with the next question. If this problem is clear, just write the clear over the comment box and then we'll move ahead with the next question. Now the next question comes from GATE Mechanical year of 1997. The problem was framed by IIT Madras. So let me read the problem word by word. We'll try to decode the problem in the simplest form and then we'll knock this problem off. A box contains 5 black balls and 3 red balls. That means you have got a box which contains total 8 number of balls. Among them the 5 are black and similarly 3 are red in color. A total of 3 balls are picked from the box one after another without replacement. The probability of getting 2 black ball and 1 red ball is. In compare with the last problem, definitely this problem is bit trickier, but still I assume you guys would be able to crack this problem. Tell me what's gonna be the best most answer for this. Tell me what's gonna be the best most answer for this. I want the answer from each one of you. What would be the best most answer for this? Tell me what would be the best most answer for this. A box contains 5 black balls and 3 red balls. So let me take a box. I have got a box. How many number of black balls we have? The number of black balls are 5 and similarly number of red balls are 3. So total number of balls are 8. Now, a total of 3 balls are picked from the box one after another without replacement. So, the first ball has to be picked out, then this ball will be dropped now. It won't be used further. And again what I'll do, the second ball would be withdrawn from the box, again it would be dropped. And now it's a turn to pick the third ball, and whether will you drop or not, that does not make any sense, because I need to just pick the 3 number of balls and we had to notice their colors. But as far as the favorable event or favorable condition is concerned, conditions are concerned, it has been clearly given the probability of getting 2 black balls and 1 red ball. 2 black ball and 1 red ball. How many black balls you want out of 3 number of collection? 2 number of black balls you want, and similarly 1 red ball you want. 1 red ball you want. Even in last class, I have clearly told about this sort of problem. Even sequence also makes sense. If you are doing the things in succession, maybe with replacement or without replacement, even the sequence will also come into the picture. Tree diagram, okay, that's fine. But I I have communicated few of the short tricks in yesterday's class. Easily you can smash the problem. See, what is the conclusion out of this? Either you can have black, black, red, black and red, or you can have sequence like black, red, black. I can say black and red and black, or red and black and black. This all three conditions satisfies your requirement where you are going to withdraw the 2 number of black balls and 1 number of red ball. 1 number of red ball. Now I wanted to ask one thing. The value over here, the value over here, the value over here, will it be same or will it be different? I have seen this thing in the last class, and probably the student who could have attended my last class could easily figure it out. The component over here, the number which would be dedicated over the BBR, BRB, RBB, would it be same or would it be different? Would it be same or would it be different? I want the comment. I want the comment. I have seen this. I have seen this. This would be same. Only their sequences would change at numerator and at denominator. But once you'll multiply, obviously the multiplication follows the commutative law. So at numerator and denominator, you'll have all three data same. All three data same. We have seen this now in the last class. So what you had to do? You had to just focus over either of one calculation and just had to multiply with 3. Just had to multiply with 3. So may I know what's the blue and red? See, black. How many black we have? How many black we have? So first black have to come out of 5 number of black. So may I know what would be the combination over here? It would be 5C1. See, again and again you need not write 5C1 because now for the time being you also had to increase your speed. We know 5C1 stands for 5. So simply I would write 5 over here. May I know in how many number of balls the one ball has been picked out? Out of 8 number of balls. Out of 8 number of balls. And now after throwing the black ball out, again I need to withdraw black ball. So may I know how many number of black ball you have been left with? Only 4 black ball. And may I know how many number of balls you had? Now only 7. Now only 7. Is that part clear? And next is red. How many number of red ball you have? So one ball has to be picked out of 3 number of red ball. That would be 3C1. And as we have seen in the last class, NC1 is simply equals to of N. So here it's gonna be 3. And at denominator you will have 6. You will have 6. Is that part clear? May I know what's the answer we are getting? May I know what's the answer we are getting? Tell me what's the answer we are getting for this particular problem. This particular problem. Tell me. What's the answer we are getting for this particular problem? See, it would become 2. It would become 2. So at denominator you can write 28, and at numerator it would become 15. So as far as the correct answer for this problem is concerned, the answer is going to be C. The answer is going to be C. Is that part clear? So probably this concept must be clear to all of us. And even the student who are following me can write an important point. I know most of the time the student do mistakes over here. Or the student will commit another mistake. They will calculate this term and this term, or the probability of the occurrence of the first ball as a black, second as a black, third as a red. Okay, they'll do that, but now they will spend unnecessarily time over this as well as this, and unwantedly the same problem which could have been solved within maybe 1 minute or 90 seconds, you will take this problem to 4 to 5 minutes, and that should not be done. So probably this concept should also be clear to all of us. Is that part clear? So, okay, now 15 divided by 28. No, 3 factorial would not come, Ambika. See, why the factorial would not come? I'll tell you. See, here, black and black, they have been repeated. here black and black, they have been repeated, and that is why 3 factorial would not come. Why the 3 factorial would come? If instead the black, black and red, now if you have got a situation where you have black 5 number, red 3 number, maybe green 2 number, and if you have a situation that one ball has to come from black, one has to come from red, one has to come from green, so there what will happen? Once you will take R, B and G, then the number of conditions which you will make is going to be 3 factorial. 3 factorial. If you want, even I can tell you why it is not. See, how many ways the BBR can be written? Now tell me, how many ways the BBR can be written? The Ambika has asked one question, that is why I am just dealing why here it is 3, not 3 factorial. Why not 3 factorial? See, how many ways the BBR can be written just by shuffling their alphabets? 3 number of times. That has been clearly written. May I know how? How? See. This problem comes from a special case where the alphabets are repeating. So far in last class, whichever the situations has been taken, in that situation either it was number, either it was alphabet, they were not repeating. So how many ways the BBR can be written? It's simply gonna be 3 factorial. It's simply gonna be 3 factorial. But as the B has been repeated twice, so it has to get divided. It has to get divided with 2 factorial. It has to get divided with 2 factorial. Is that part clear? So now may I know what would be 3 factorial divided by 2 factorial? It would be simply equals to 3. It would be simply equals to 3. Agreed, Ambika, what I am trying to say? So this thing must be clear to all of us. This thing must be clear to all of us. No, just B and B is getting repeated, no? That is why it's gonna be 3 factorial divided by 2 factorial. End of the day, we result 3. Now, if you want, I can take a few of the important thing. Now, if I take an example, we have a name Rohan. How many ways the Rohan can be rewritten? Obviously, all 5 alphabet has to be used. How many ways the Rohan can be rewritten? It would be simply equals to a 5 factorial. Why so? Because none of the alphabet is getting repeated. None of the alphabet is getting repeated. Now, if I take another situation, it's the Aditya. So now I wanted to know in how many ways the Aditya can be rewritten. Obviously, I had to use all of the 6 alphabet. So it's going to be simply 6 factorial divided by of, see, the A got repeated twice, no? So here 2 factorial will come. Similarly, if you take another situation, now, see, now you have another word, Elephanta. How many number of alphabets it has? 1, 2, 3, 4, 5, 6, 7, 8, 9. May I know by just using this 9 number of alphabet, how many distinct words can be formed? Now what will happen when the E and E will change their location, or A would change their location? There is no formation of new word at all. So that is why what is gonna be the result out of this? How many of alphabets you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And E got repeated twice. A got repeated twice. Is that part clear? And whatever the answer comes, that would be the different ways 9 alphabet long word can be fabricated. 9 alphabet long word can be fabricated. Is that part clear? So probably this must be clear to all of us. So let me go ahead with the next question. Yes. This comes my question number 3. Now again you guys had to solve this problem and get the answer out of this. If you talk about the problem has been seen in GATE electrical year of 2003. The problem was designed by IIT Madras. So let me read the problem word by word. A box contains 10 screws, 3 of which are defective. two screws are drawn at random with replacement, the probability that none of two screws is defective will be. We have got the 4 different number of options. It was a problem of MCQ. It starts from 100%, 50%, 49%, none of this, none of this. See, deliberately I have taken this problem because the last 2 problems were the problem which were based on without replacement, but this is the problem where the replacement was made. That means it's a problem with replacement, with replacement. Is the part clear? So now tell me what's gonna be the best most answer for this. See, if you talk about the graphical understanding or visualization of this problem, how many number of screws you have? 10 number of screws you have. Out of 10 number of screws, 3 are defective. Out of 10 number of screws, only 3 are defective. See, I have seen many of the time the student do mistakes over here. So out of 10 number of screws, the 3 number of screws are defective, and similarly the remaining 7 number of screws are good or they are non-defective. So if we talk about the number of defective number of screws, so 3 are the non-defective, and similarly remaining number of screws are good, or they are non-defective. They are non-defective. What the problem is looking for. See. 2 screws are drawn at random with replacement. That means randomly 1 screw was withdrawn. 1 screw was withdrawn. We saw whether it's a defective or non-defective. I kept it back. And again I well shuffled this box, and again I withdrew another screw. And again I checked whether it was defective or non-defective. Whether it was defective or non-defective. Whether you will keep it back or whether you will be keeping outside does not make any sense, because it's a last screw which you are observing now. See sir, the answer have started coming. Anyways, we'll try to understand how the question will be followed. Both of them has to be coming from the good lot of these screws. So the first has to be good, then the probability of the second screw is to be good if the first screw was good. So may I know what's gonna be P of G? P of G is simply gonna be the 1 screw has to be withdrawn out of 7 number of good items. So 7C1 is simply gonna be 7. Out of 10 C1, and 10 C1 would be simply equals to 10. But see, although you are using a conditional probability over here, but the good item which was withdrawn was kept inside. That means as far as the structure of the sample space is concerned, it remained very same. The total number of defective items 3, total number of good items 7, total number of items, that's again 10. So again you go ahead with 7 divided by of 10. And here it's gonna be 49 divided by 100. Now, if they are seeking the probability in terms of integer, it would be 0.49, and if they want in terms of percentage, it would be 0.49, which will get multiplied with 100%, and the result would be simply equals to 49%. So nobody should get confused how the value have become 49. 49 is percentage, and even the probability can be expressed in terms of percentage. If this is clear, you can just write clear, and then we shall try to move ahead. Clear now? Okay. So go back to the digital board. And now we are going to write few of the important facts. Write it down. Type of events. Now you will come across with several number of problems in your GATE examination where you need to deal with maybe 2, 3 or 4 number of events. And what happens once you deal with more than one number of event, dealing with those sort of problem becomes very difficult. And even the event also follows a certain relationship between each other. maybe they could be dependent, they could be mutually exclusive, they could be independent, and the way they are making relationship between each other, even the formula also gets changed. Like in case of mutually exclusive event, P A intersection B becomes 0, whereas in case of independent event, P of A intersection B becomes P of A dot P of B. That means the formula itself have got the validity as per the relationship between the events. You need not to worry about it. Whatever I have said just now, you just had to focus over the type of events. Like if you have 2 or more than 2 number of events, in which category they would fall. Is that part clear? Now, the first kind I would be writing as mutually exclusive event. Mutually exclusive event. See, name is not that important. The basic concept behind the mutually exclusive event is more important. Mutually exclusive event. What does it mean by the mutually exclusive event? Exclusion, separation, bifurcation. What does it mean of it? That means if you are in this pool, you are not in this pool. We used to have grouping in colleges, no? If you are part of this group, you cannot be the part of this group. So I can say this group and this group is mutually exclusive group. We used to have that. Yes or no? I do not know about the boys, but yes, girls do have. Anyways, keep aside. Mutually exclusive event. Mutually exclusive event. That means if you have an event which is there in first group, it can't be in second group. And if the event is the part of the second group, it can't be in the first group. Is that part clear? May I know what does it mean by the mutually exclusive event? Events are said to be mutually exclusive event if occurrence of one event restricts the occurrence of other. Write it down. The two events are said to be mutually exclusive event. Two events are said to be mutually exclusive event. Two events are said to be mutually exclusive event. Two events are said to be mutually exclusive event. ME events if occurrence of one event restricts occurrence of other. Occurrence of other. Either you can understand in terms of the Venn diagram. Let's take, it's your Venn diagram, and within the Venn diagram, now you have taken two different events. Let's take the first event is E1 and the second event is E2. Within the same sample space, you had the two different events and they do not share any common area. No common area. In that case, the E1, which is event, E2, which is event, would be called as the mutually exclusive event. That means if you have any element which is a part of E2, it can't be the part of E1, and if you have any element which is a part of E1, it can't be the part of E2. Is that part clear? Now let me go. Now in future, you also had to deal with the intersection. What does that basic mean of the intersection? The name itself is self-explanatory. What is the common area or common elements between E1 and E2? Keep in mind, if E1 and E2 are the mutually exclusive event, the intersection between E1 and E2 will be a null matrix or will be a null set. Or in future, if we talk about the probability, definitely we'll be talking about this also in great detail. Probability of E1 intersection E2, you will get to know the result is simply 0. The result is simply 0. Result is simply 0. Is that part clear? Is that part clear? Now, still I know many of us would be in great confusion. Sir, that's fine. Graphically as well as conceptually, the things looks okay. Okay, sir, this is the mutually exclusive event. But until and unless by watching the problem itself, if you guys are not able to figure it out, the problem comes from mutually exclusive or not, you may not be able to solve that problem. So you should also have a smell of the problem, that the problem is falling whether from the mutually exclusive event or not. So let me take an example and we'll try to decode whether it's a problem of mutually exclusive event or not. See, a fair die is rolled. Now you guys should not have any doubt over the fair. Die is rolled. Die is rolled. Rolled. Let's take few number of events are fabricated. Let's take the E1. E1 is the event for getting even number. Similarly, E2 are the event for getting event or which have the collection of all odd numbers. And similarly, let's talk about E3 has the collection of event of all prime numbers, all prime numbers which a die can have. So E1 is gonna be a set which will include all of the numbers which are even. So here it would be 2, 4 and 6. Here it would be 1, 3 and 5. Keep in mind 1 is not a prime number, so it starts from 2, goes to 3 and rest at 5. So I would like to know one thing from you guys. E1 and E2, whether they are mutually exclusive event or not. E1 and E2, whether they are mutually exclusive event or not. E1 and E2, whether they are mutually exclusive event or not. Yes, they are. Why? Once you talk about the elements within the set, none of the element which is there within first as well as second element. Obviously, there is no element as such which is the part of the first set as well as second set, and by default you can say the E1 and E2 are mutually exclusive. If you want, you can check it out. Anyway, set theory is not there as a part of our syllabus, so I need not to go into the core detail of the set theory. If you talk about the event or the element which is common there over the set E1 as well as E2, you will get a null set. And that is why it's a mutually exclusive. And similarly, if we talk about E2 and E3, where I should write? Now, if we talk about the E1 as well as E3, and similarly E2 and E3, may I know whether they are mutually exclusive or not? So just focus over the elements which are possessed by both of the sets. Either it's a E2, either it's a E3. If we talk about the E2, which includes 1, 3, 5. Sorry, if we start with E1, which includes 2, 4, 6. If we compare with E3, which includes 2, 3 and 5. Now, 2 is the responsible element which will keep E1 and E3 non-mutually exclusive. And similarly, once you compare E2 as well as E3, the 3 is the element which is common in both, and hence again it can't be mutually exclusive. But anyways, in future we are going to discuss about another kind of events when the events are gonna be dependent on each other. When you will be saying that the two events are dependent, the events are said to be dependent if they contains or they consist at least one common element in both of the sets. So E1 and E3 obviously would not be mutually exclusive. They are dependent event, which we are going to discuss just after this concept. Is that part clear? So let me go. Let me go. Yes. Now the next kind of event which comes into the picture is gonna be dependent event. Dependent event. Dependent event. Now the name itself is self-explanatory. If you have got the two number of sets, at least one element must be common in both of these sets. So you can write over here. You can write over here. You can write over here using Venn diagram. The Venn diagram will give you a better insight of the dependent event. Venn diagram. Venn diagram of the dependent event. So let me take a sample space S, and now let me take the two different events E1 and E2, and once we draw that event E1 and E2, you'll get to know, either you can write E2 or E3, whatever it may be, they are sharing a common area, or they are sharing a common element. They are sharing a common area, or they are sharing a common element. By default, in that case, the E1 and E2 becomes dependent events. Dependent events. Yes. And in future, if you talk about the intersection between the sets E1 and E2, obviously it won't be a null set, because at least one element would be there which is common in E1 as well as E2. So in future, whenever we talk about the probability of E1 intersection of E2, where the E1 and E2 are the dependent event, the value would not be 0. Always you will have a finite value in between 0 to 1. Whereas if you talk about this scenario, the probability of E1 intersection E2 would become 0. That is what I am saying. No? You cannot just say the probability of the intersection of E1 and E2 would be 0, or the probability of E1 intersection E2 would be non-zero. That solely depends which type of events you are going to deal with. Is that part clear? Last never the least, let me go into the next. Here we are going to discuss about the independent events. Just a minute. Independent events. Independent events. May I know what does it mean by the independent events? See, in case of dependent as well as mutually exclusive event, both of the events were kept over the same sample space. In one, occurrence of one was restricting the occurrence of second. In second, they had at least one common element. But as far as the independent events are concerned, the both of the independent does not care whether it has happened or whether it has not been happened. Like. You can take an example. Like the cricket match is going on between the West Indies and maybe Australia, whereas the another match is going somewhere else, maybe in different country, between the New Zealand and South Africa. So may I know the result which will come out from the first match and the result which will come out from the second match, whether they are mutually exclusive, whether they are dependent, or whether they are independent. Obviously, absolutely they are independent. Why? Because the two teams are playing in the different environment, and similarly the another two team is playing in the different environment, and that too, obviously they all are the four different teams. So one of the important thing, if we talk about the probability, maybe winner or probability of the winner in first match and probability of winner in second match, and end of the day, if you would like to have a relationship between their events, they are gonna be type of independent events. They are gonna be type of independent events. So write down one important point you can write, and what it is, one important point you can write, what it is. Independent events independent events are on two different sample space, sample space. Is that part clear? And the name independency indicates the outcome of one event, one does not have impact from second, So let me give you an example and you guys would be able to understand the better way. Now you have a die, you have a fair die. What about the fair die, which we have already talked in the great detail in the yesterday's class. Now you had the second die, Let's take, we have made an event E1 which is getting even number in first roll or in first die, and if we say the E2 is the getting odd number in second die. May I know which type of events they are, the E1 and E2, whether they are mutually exclusive event or whether they are independent event. I want the reply from each one of you. Which type of events they are, whether they are mutually exclusive event or whether they are independent event. Mutually exclusive event or the independent event. Just give the answer in the fast manner. Tell me. So still I find many of the students would say, sir, it's a mutually exclusive event. Why? Because here we are going to discuss about the even numbers and here we are going to discuss about the odd numbers, and if the even is there, the odd cannot come, and even the odd is there, even cannot come. No, you are wrong, boss. Here we are going to discuss about the even number in the first trial, whereas we are going to discuss about the odd number in the second trial. If the even number or the selection of the even number as well as selection of odd number is just dedicated to the first trial itself, in that case the E1 as well as E2 would become mutually exclusive event. Could you understand? Deliberately I have designed the problem in such a way that the most of the student would get trapped over here and they'll start thinking, sir, why you are saying they are not mutually exclusive? They are not mutually exclusive. Yes, if E2 also come from the same sample space, I could have said E1 and E2 either would be mutually exclusive if they do not have any common element, or they would be dependent. So as far as a case where both of the event comes from the same sample space, either they would be dependent, they would be dependent, or that they would be mutually exclusive. But if they comes from the two different sample spaces, no, you will not say whether it's a dependent, you will not say whether it's a mutually exclusive. By default, they would be independent. Is that part clear? So E1 and E2 are the independent. Event. Is that part clear? So now let me go ahead with few of the important formulas, and keep in mind, if you guys have a clear-cut idea about the each and individual formulas, its validity, and when and how this formula has to be applied over the different varieties of the problem, end of the day, you are not going to leave even a single problem. And I know most of the students still find the probability, even the word problem related to the probability, very difficult. But once you go through this sort of important formulas, you will have a little bit idea about the each and every individual part. End of the day, I am going to take plenty amount number of problems. Yes. So write down Important axiomatic formulas or important formulas, you can just write. Important formulas. Important formulas. So let me go ahead, or let me state few of the important formulas. See, the first formula would be, or first conclusion would be, if we talk about the probability for the occurrence of event E, we write it P of E. So nobody should get confused the what P of E stands for. The P stands for the probability and the E stands for the event for which the probability is assessed. Yes. The P of E would always be in between 0 to 1. In between 0 to 1. Now the people may ask why it's in between 0 to 1. We have already talked about it, m divided by of n, where the m is number of favorable event out of the sample space. That means the size of the sample space would always be larger than the size of the favorable event, or the worst case, the number of favorable event could be same as the size of the sample space. So it would be in between 0 to 1. That means numerator would always be lesser than denominator. We talk about the m divided by of n, that means m is always going to be lesser than n, whereas m as well as n both are natural numbers. Is that part clear? Now let me talk about the next. If a event having probability is equals to 0, in that case that event E is called impossible event. Impossible event. Rarely it happens. See, if you are tossing a coin and you are searching what's the probability for getting 6, your 6 would come in die, it won't come in tossing a coin. And similarly, if you are rolling a die and now you are saying, sir, what's the probability for getting head? Head would not come with die. That is what I am saying. If you are searching something very unexceptional which is not there within the part of your sample space, that event is going to be an impossible event, like getting 6, like getting head. So now if you talk about the head in die, the head is not the part of the sample space in die, and similarly 6 is not the part in the sample space of head and tail. Is that partly what I am saying? So they are said to be impossible event. And that is why in few of the books you will see the P of E is in between 0 to 1. They exclude 0 and 1. Why? Because the 0 and 1 does not take place in real world. Nobody is going to ask what's the probability for getting 6. Nobody is going to ask what's the probability for getting 10. And that is why few of the books, they exclude 0 as well as 1. But anyways, let me include this. Now, you have a special condition. When you had a probability of a certain event and which got to be 1. That means your event itself covers your complete sample space. What does it mean of it? A coin is tossed. What's the probability for getting head or tail? Boss, either head or tail will only be coming. And if you are saying the head is also your favorable condition, tail is also your favorable condition, end of the day, number of favorable event, it's gonna be 2. Total number of event in your sample space, that's gonna be 2 divided by f1. Similarly, now if a die is rolled, find the probability for getting our number as a 1, 2, 3, 4, 5, 6. So keep in mind, whenever you include your complete sample space, the result simply becomes 1. Is that part clear? Now, sometime you go across the probability of non-occurrence of event. See. Non-occurrence of a certain event itself is an event. Like if you are rolling a die, find the probability for not getting 2. That means initially the set was 2 and now you are saying not getting 2. So the next set would be 1, 3, 4, 5, 6. That is what I am saying. A prime or A bar will make another set or another event, and again you can calculate the probability for that. Agreed? You can go ahead with this derivation, or otherwise simply you can write 1 minus of P of A. 1 minus of P of A. From where it have come? See, non-occurrence of event A plus of occurrence of event A would complete your sample space. Result would be 1. Result would be 1. Either the A would occur or either A will not occur. And if you take the probability of both together, the result would be 1. And that is what I am saying. The P of A bar 1 minus of PA. Yes. You can write the next important point. Sometime you also had to play with the inversal law. Inversal law. You need not to write the laws and all. Like in future, if you are playing with the union and you need to take the bar or the prime of the union, I'll give you few number of examples as well as practical problems where this formulas would be needed. So P of A union bar is equals to of P of A bar and P of B bar. P of B bar. Similarly, the situation just reverses like here it would become P of, same concept goes with the Boolean algebra, no? In case of ORing and ANDing, come from there only, no? Union is nothing but the ORing between all of the Boolean algebras, and ANDing, or sorry, intersection is nothing but the ANDing between all of the Boolean algebras. But anyways, I need not to go over the Boolean algebra. May I know the quality of video and audio, is it perfect or not? Because in between I found the video was getting stuck. So I want the input from each one of you. The quality of video is okay, no? The quality of video is okay, no? Tell me over the comment box. The quality of audio and video, is it perfect, no? Okay, then it's fine. Then it's fine. Now, you will come across few more important aspects. You will come across few more important aspects. May I know when the union is being used? This symbol is called union symbol. Union. The name itself is quite self-explanatory. If we are making union between me as well as my student, either I am there, well and good, either my students are there, well and good, either me and my student both are there, well and good. Union, that means either and or. So usually you have a sentence like either or just or. You would be using union. Now the next sign goes for the intersection. May I know what does it mean by the intersection? That means you as well as me. How the class will happen? When you are there and as well as me, I am here. So you can say the smooth teaching would be there, or smooth class would be there if I am functioning well as well as you guys are reading well. So you can say in that case the intersection between you as well as me has to be taken place. When it takes place? When the event and event 2 is being talked of. Both event E1 and E2 has been talked of, or occurrence of event 1 and event 2 has been talked of. Is that part clear? Now let me take few number of important formulas based on this only. Let me go. See what is happening over here. Try to understand in this way. May I know what would be PA union B? Because you need to deal with many of the cases when you have got the two number of events and you are going to discuss about their unions, and after unions you are going to discuss about its probability. May I know what would be the formula for this? Tell me each one of you. Let's take it's my sample space. We have got the two events, A as well as B. This region is nothing but the region of A intersection B. May I know what about the PA union B? The PA union B, let me take the pinkish curve. This is gonna be PA union B. This complete region. This complete region. May I know how the complete region would get covered? See, you can take the first area of A plus second area of B, but once you are adding the area of A as well as B, what is happening over there? The intersection part have come twice. So once we had to remove that part, so simply PA plus of PB, and as in PA and PB, the PA intersection B was a part of P of A as well as P of A intersection B was a part of P of B, so it have come twice. Once has to be knocked off. Once has to be knocked off. So you can say very well, whenever we are dealing with the problem where we need to deal with the probability of A union B, the formula is gonna be P of A plus of P of B minus of PA intersection B. May I know when this formula is true? When A and B are dependent. Dependent. A and B are dependent. Similarly, the same formula can be restructurized a bit. It could have been straight away written as PA plus of PB. We have already seen in case of mutually exclusive event, the A would be separated and B would be separated, and together they will not make any common area, or I can say here it would be simply 0. So you can write if A and B are mutually exclusive event. But nobody should use either of the formula when A and B are independent. I will show you how to deal with those sort of formulas. That is what I am saying. No, I have seen many of the times students just by heart these formulas and they will be using these formulas anywhere, wherever they want. That is wrong way. Till this point, each and everything is clear. You can just write over the comment box. Is that part clear? Okay. Now we'll go ahead. Now you have a special condition. Although once only the problem have come, and probably the problem have come in instrumentation. If you have the union between the three different events A, B and C, and for the time being I have assumed they belongs from the same sample space. Let me go up. Same sample space. May I know what would be the formula for it? Like this: A, B, C. It's the event A, it's the event B, it's the event C. So now what's happening over here? Again the same fundamental has to be used. It's a P of A, P of B, P of C. What happened now? See now. In between A and B, this area has been calculated twice, obviously in A and B. So you had to remove once. Yes. Similarly, it's in between B to C. Similarly, it's in between C to A. And now one of the worst part has happened. This portion was taken out thrice. Once with A intersection B, once with B intersection C, once with C intersection A. And once we talk about the union, that means we need to cover the complete area. That means this area has been taken thrice outside. First time it was with the A, second time it was with the B, third time it was with the C. But now all of the three portions of A intersection B intersection C has been taken out. So again it has to bring back. And how you will bring back? And that you will be bringing it back by taking this. Yes. Is that part clear? Now I need to discuss a bit about few more important formulas. So let me go down. If you have the probability of A intersection B, and if A and B are found to be independent event, then their intersections simply would become their multiplication. Keep in mind, A and B are the independent event. Yes, B gonna be independent event. Let me go ahead. Let me discuss a bit about the conditional probability. And I found that most of the students find themselves difficult, but it's a very important topic. Conditional probability. What does it mean by the conditional probability? So we are going to discuss about the occurrence of a certain event. If we know a certain event is already occurred, we can have that situation. So this type of problem comes under the conditional probability. Like P of A by B. Each and everyone should write the physical significance of P of A by B. In few of the books, it's been written as A denominator B. Numerator is the event for which the probability is assessed. I repeat, numerator is the event for which the probability is assessed. Denominator is the event which is already been done, or which is already been taken place. So may I know what the P A by B stands for? It's a probability for the occurrence of. It's a probability for the occurrence or of the occurrence of the occurrence of A when B is already occurred. Yes, and mathematically it can be written as P A by B is equals to of P of A intersection B divided by of P of B. You should remember this. Yes, you should remember this. And once I'll take a plenty number of problem, you had to get connected with this formula, because we have taken good amount of questions which probably we are going to take today. Is that part clear? So let me go down. Now you can have a special condition. Which could be that condition? The condition could be you are interested in probability for non-occurrence of event A. As I have said, non-occurrence of a certain event itself is an event. Like non-occurrence of even number by default would become odd number. Non-occurrence of prime number by default it will become composite number. See? So you need not worry about it, sir. How the probability is applied over non-occurrence of a certain event. Yeah, non-occurrence of a certain event itself will make a rest of the event from the sample space. Yes. Suraj Singh need not to worry about here until and unless you are not thorough with this. So you will not be able to even touch the base theorem. The base theorem would be taken separately if the time permits, today itself or maybe tomorrow. But focus over this. May I know what would be the result out of this? It would become, instead the A everywhere A bar would be fed in. So let me do one thing. Let me take a sample space. It's my sample space. We have got the two different events and they're sort of dependent event. Yes. If you are talking about the conditional probability, for the time being I have taken a situation where the A and B are the dependent event. May I know which reason the P of A bar intersection B covers? See, A bar means the complete reason outside of A, and similarly B, if it takes an intersection with B, that means you come to a situation where the PA intersection B, or for the time being, A intersection B covers only this region. Covers only this region. So may I know PA intersection B, can it be written as P of B minus this region? Minus this region. What is this region? This region is nothing but A intersection B. Obviously it can be. Divided by of P of B. Divided by of P of B. P of B. Obviously. So P of B divided by P of B goes off, and P of A intersection B divided by of P of B was equals to of this. So simply it can be written as. Yes. Now I am going to take good amount of questions. Now I am going to take the good amount of questions. You guys should have at least a little bit idea about these formulas. This formulas. Although it's not the formulas, they are just brought out from a certain logic. And with each and every problem, you cannot start from the scratch of the logic. Otherwise, that problem may take 4 to 5 minutes. And definitely it would not be good for any competitive examination. And that is what I am saying. Few of the insights you should have remembrance. Among them, yes, sample space is being taken as complete event, the probability would become 1. If impossible event, that means the event which is not there in a part of your sample itself. And if you wanted to get the probability of the occurrence of that event would become 0. Similarly, if you talk about the non-occurrence of a certain event, if you talk about its probability, it would be simply 1 minus of PA. And similarly, it goes off. And this derivation, I need not to say now, I think. You need not to say now. If you want, I can show you how it has happened. Everything have got its own basis. See? If you talk about the A union B, may I know what would be A, what would be B, and what would be A union B? Let's take it's the event A and it's the event B. Event B. If we talk about the A union B, definitely this complete reason would be A union B. But once we talk about the A union B bar, A union B itself is an event which was a composite area between A and B. Now the A union B bar would be this reason. Would be this reason. Yes. May I know how it can be written in a different way? Yes. This reason is outside the A. This reason is outside the B. You can say A intersects A bar, that would be this reason, B bar, that would be this reason, and the common reason between the A bar and B bar would be this. Sir, if you would go through problem solving instead of going through, no, need not to worry about it. Suraj Kumar, I am there in this field probably more than 10 years, and I know how to feed each and everything in the proper way. You need not to worry about it. Once I'll jump into the question now, you'll ask, sir, what would be its fundamental? Can you tell me a little bit about this? No, you need not to worry about it. And similarly, this goes on. Yes. Okay, so let me do one thing. Let me go into the question. Yes. So the first question comes in a form of fourth question. Tell me what's going to be the solution or the answer for this particular question. If you'll say, I can read this problem word by word. A coin is tossed 3 times. I'll repeat. A coin is tossed 3 times. It is known that out of 3 tosses, at least 1 is a head. The probability of the other 2 tosses also being head is. See, what has been asked, a coin is tossed 3 number of times. It is known that out of 3 tosses, at least 1 is head. Keep in mind, few additional informations are being supplied with the problem. So anyway, this problem has a smell or essence of a conditional probability. That means something has already been happened. Anyways, the probability of other 2 tosses also being head is. Now this problem can be solved using the two different methods. Suraj, now you can see you need not to worry about anything if you are there in our channel or our platform. Now method 1, you can have a manual method. See, if the 3 coins are tossed together or 1 coin has been tossed 3 number of times, how many number of events you'll have? 8 number of events you'll have. If you want, we can list it down because we are having a manual understanding of this problem. See, whenever you are dealing with this sort of problem, when the two coins are getting tossed, you can just assume it's a number system which we used in digital. May I know what used to be that? 0, 0, 0, 0, 0, 1, 0, 1, 0. Similarly, the 0 has been allocated to tail and 1 has been allocated to head. So the number of possibilities are going to be 0, 0, 0. You can simply write this as tail, 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 because end of the day you will not have any confusion. Then head, tail, tail, head, tail, head, 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 tail, and end of the day it's a head, head, and head, 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 and head. See, as far as the given data is concerned in the problem, it has been clearly observed at least one had been occurred. That means out of 8 number of possibility, you had to rule out this possibility. You had to rule out this possibility. So may I know what is the size of your sample space? What is the size of your sample space? Although if we talk about the complete size of the sample space, the number of events in the sample space, it would be 1, 2, 3, 4, 5, 6, 7, 8. But out of 8 number of events, the 1 has been removed it out because the 1 data was clearly given to you. Because the 1 data was clearly given to you. Yes. Could you agree it or not? Now, what is being asked? The probability of 2 other tosses also being had. May I know what is the size of your sample space after considering this input? Now the size of the sample space has been shrunk to 7. And now if we talk about the number of events which are the favorable events out of your sample space, you need not to see or you need not to bother about this event at all. You should remove it at a first instance. Yes. Now number of the favorable event, if 1 had already been occurred, obviously in all of the 7 opposites at least 1 had takes place, but you had to look into the situation when all of the head have been taken place. So may I know how many number of event you have? Only 1 event out of 7 number of event. I know. Now the each and every one will have a little bit pain, and that is why only good amount of problem or the good quality of problems we are going to discuss over the today's class. Now just wanted to ask from each one of you, could you figure it out this concept or not? Could you figure it out this concept or not? If it is yes, just say yes, and if it is no, just say no. I'll repeat it again. See, this was very important. And this problem has come in GATE Metallurgy year of 2016. The problem was framed in that year by ISC Bangalore. Now I will take another path. That is what I am saying. No, that is what the formula was clearly written over there. I would be solving this problem using the conditional probability. Now, let me decide the two event. Let's take the A is the event for all faces as head. Yes, that is what we want. B, event at least one face as head. May I know which value you are looking for? Anyways, along with A and B, you can also calculate PA as well as PB. PA as well as PB. You can calculate that. Or do one thing. You can straight away come to the formula. May I know which value you wanted to calculate? You wanted to get the probability for the occurrence of the event that all of the faces are head when the B is already occurred. Yes or no? Yes. Now you guys would be able to understand little a bit with the concept of conditional probability. You are not only calculating the P of A, because one of the answer we have got it 1 upon 8. Definitely the mistake was same. You guys simply jumped over the P of A, but now we are focusing over the P of A when the B is already been occurred. May I know what's the formula we are going to use over here? The formula would be P of A intersection B divided by of P of B. P of B. Now I want from each one of you what would be the exclusive value of PA intersection B and what's going to be the exclusive value of P of B. You just had to give over the answer and we'll get the answer out of this. PA intersection B, when both of them are appearing together, event for all faces head and event at least one face as head. May I know what would be the event B? The event B would include the first one, second one. See. Now I am not doing any manual calculation, so you need not to drop about this because each and everything would be taken care in the great detail. So now try to understand if we talk about the A event for all faces as head. So what it is? That is what this. And if we talk about the P of A, if at all it is required, P of A, simply it would be one time it has happened out of 8 number of times. Yes. Now, if we talk about the P of B, event at least one face is head. So out of 8 number of event, only you have to leave the first event. The remaining event has at least one face as head. So may I know what it is? 7 out of 8. You need not to remove any of the given data from your sample space. Yes. Now, if we talk about P of A intersection B, may I know what it is? It's a situation which satisfies the requirement of event A as well as event B. What it is? Event for all faces head. Event for all faces head. Only one. That is H, H, H. And similarly, event at least one face as head, which includes TTH, THT, THH. You can take this all as its sample space element. May I know what would be the intersection between them? Only one event, which satisfies the requirement of A as well as B. Although I can write each and everything in the great detail, but now I understand the gate is not very far away and you guys should understand the each and everything at least using a best concept. Yes. So let me feed the data over here. It's a 1 upon 8 and P of B is nothing but 7 upon 8. May I know what's the answer over here? It's a 1 upon 7. It's a 1 upon 7. Yes. If it is clear, just write clear, then we shall move ahead. If it is clear, just write clear, then we shall move ahead. Yes, this sort of problem can come in your gate examination, and as I can understand, most of the students are going to stuck on this sort of problem. That is why a bit trickier problem I have consolidated and going to show front of you guys. Yes. Now, this sort of problems are repeatedly coming. It has got a different flavor together. Two players A and B alternatively keep rolling a fair dice. The person to get a 6 first wins the game. Given that the player A starts the game, the probability that A wins the game is 5 by 11, 1 by 2, 7 by 13, 6 by 11. The problem have appeared in gate examination year of 2015. The problem was framed by IIT Kanpur. This sort of problem are repeatedly coming. So far, this problem have come with the die. Sometimes this problem do from coin. Tell me, how will we go ahead with this sort of problem? See, what is happening over here? Just try to understand in the practical scenario. The two players are there. Let me take, I am player A and you guys are player B. The one player, you can assume yourself as player B. What has been taken place? we had a die. We had a die. The whoever gets 6 first wins the game. And anyways, in the problem it has been clearly written, the person who is going to start the game is me. So what I did? I rolled a dice. If I am getting 6, I am the winner. Yes. But next time, if I could not get 6, now the die will be passed to you. And if you get 6, you are the winner. But as far as the problem is concerned, I need to focus over the probability when I am the winner. That means whatever the situation you are going to take in the consideration, I should only be focusing over the event in which I am the winner. So how this situation will take place? How this situation will take place? Is that part clear? How this situation would take place? See, first situation could be, I am not going to write each and everything in great detail. Why? Because now you have to concise the steps. Then only you can process a certain problem in the fast manner. See, when the player A would win the game in the first trial itself, see, he has thrown a die and got 6. May I know what's that probability? The probability is gonna be 1 by 6. Yes. Or why the or is coming? That means the first person or me could not get 6 in the first trial, but still I am the person who had to win the game. So how the game will come back to me? It will come back if in first trial I could not get 6. That means it was a probability for getting 1, 2, 3, 4, 5 out of 6 number of event, which is 5 by 6. And even now the game will go to the player B, which is you guy. You also could not get 6. That means you could get either 1, 2, 3, 4, 5 out of 6 number of item. That's a 5 by 6. Again game came to me and I got 6. Or I can say first trial I got 6. First trial I could not get 6 and you could not get 6 and I could get 6. Or you'll have a situation in first trial I could not get 6, you also could not get 6, I also could not get 6, you also could not get 6, I got 6. Why the 1 upon 6 5 by 6 is keep coming? Why the 1 upon 6 5 by 6 is keep coming? See, if you're talking about the occurrence of 6, it's 1 upon 6. If you're talking about non-occurrence of 6, it's gonna be 1 minus of 1 by 6. That's gonna be 5 by 6. And this process may go on. And one of the most beautiful part about this series, it's gonna be geometric series, where the first term A is equals to 1 upon 6. And if you talk about its common ratio, either you can take A2 divided by A1 or either you can take A3 divided by A2. You will get to know it's just simply gonna be 5 square divided by of 6 square. That's a 36. And may I know how many number of terms you'll have? If you have a bad luck in that day, that process could be keep going on till infinite number of time. And one of the most important thing, if mod of r is lesser than 1, in that case the sum of that GP converges to a certain fixed value, which is equals to of A divided by 1 minus r. Yes, convergency I need not to discuss, at least here. Otherwise, it's called a convergency test. May I know what's the A over here? The A is simply going to be 1 upon 6 minus of 25 divided by 36. Yes. So here it becomes 1 upon 6, 36 minus of 25, that would become 11 divided by 36. 36 goes up. 36, okay, it's gonna be simply equals to of 6 divided by of 11. So the best most answer is gonna be 6 divided by 11. Is that part clear to all of us? Yes or no? Yes, if it is yes, just write yes over the comment box and then we'll move ahead. Now I would ask to have a little bit change over this problem. See, even you had to be winner. That means I am the person who had to be winner, but the problem was changed a bit. What it is? Instead starting the game with me, now the turn has been given to you. Turn has been given to you. Would it be having the same probability or would it be having a different probability? Would it be having the same probability or would it be having a different probability? Just I want the input from you guys. See what happened? Still I want the probability for win for me. But now the starting turn was not me or not mine, the starting turn was given to you. May I know the probability, would it be same or would it be different? Would it be same or would it be different? See, if the probability is higher over here, definitely I am the person who will start with the game. I will say, no yaar, you keep aside, I am going to start the game. Why? Because the probability favors me or favoring me. And if in both of the cases we are getting the same probability, I would just say, yaar, either you will start, either me I will start. End of the day, we are not having the same value. Would be same. Anyways, different, same. The two answer we have got it. See, now, in second case, you are the person who is going to start the game, but the probability is fixed when I am going to be winner. That means first time how I would win, that the first trial was given to you and you got anything apart from 6, that's a 5 by 6. Now the turn would come to me and I have got it 6 and that's a 1 upon 6. Or first trial you lost, second trial I lost, third trial you lost, fourth trial I won. Similarly, this process would keep go on, and whenever you need to deal with the AP and GP, at least used to have the 3 term, such that you'll have a clarity whether their common differences or common ratios are same or not. Definitely you'll get a common ratio same. Now may I know what's the first term? That's nothing but 5 divided by 36 divided by of 1 minus r. May I know what's 1 minus r? If you take a difference or the division between the A2 as well as A1, 1 upon 6, 1 upon 6, 5 upon 6, 5 upon 6 goes off, and here it's gonna be 25 divided by 36. 25 divided by 36. And here the value is gonna be 5 divided by 11. See, you guys were calculating this. This and this has to be complement, no? Once you'll add them together, the value has to be 1. That's the first thing. And now, could you understand or not? Now the probability has been reduced. Initially, my winning probability was 6 upon 11 if the toss or rolling was started by me. And similarly, now the probability of mine win has been got down to 5 divided by 11 if the game was started by you. So definitely now you guys would have a clear-cut idea. If the game would be designed in my favor, definitely I would be the person who would start the game. Is it part clear? You can change this problem again. And see, this problem are repeatedly coming in the different ways. Like. 2 players A, B alternatively rolling the dice, the person to get even number first wins the game. Given that the player A starts the game, the probability that A wins the game. Done. Blah, 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 blah. And here instead this 6, they can say maybe what they can say, prime number. Even they can say instead the die they can have a coin. A coin is tossed. If head comes first, the person wins. Now the game was started by A. What's the probability that A gain the game? Is that part clear? So you can have this sort of problem. So go ahead with the next problem. Yes. The each and every problem I tried to have a little bit different flavors. So I gone through the each and every problem. I tried to have a varieties in the problem, and definitely you guys might be finding that the each and every problem are not having any semanticity. Deliberately they have been picked up in the way. Need not to worry about it. The problem will come in the gate examinations probably in the same range or in the same reason. May I know what would be the answer for the question number 6? What would be the question or the answer for the question number 6? Once we go ahead with the problem and try to figure it out each and individual word, let me read each and individual word. 7 car accidents occurred in a week. What is the probability that they all occurred on same day? Nowhere it has been written, but one thing should have been written with this terminology, or you can assume one thing. Their accidents, whether they are dependent or independent. I want the reply over the chat box. The accident, how many number of cars you have? 7 cars you have. So let's take the car number 1, 2, 3, 4, 5, 6, 7. The accident of car number 1 as well as 2 as well as 3 as well as 4, whether they are dependent or independent. Nowhere it has been written, but the problem can be made in the form of dependency also. Like if first car got collided with the second car, that means the accident has been taken place with first car as well as second car both. First car as well as second car both. But as far as the problem is concerned, it looks something very different. Like the first car got collided with wall, the second car maybe collided with tree, the third car got collided with a certain bus. That means it looks something like all of the cars are independent while making accident. Yes or not? Yes, no. If you'll make dependency, the problem will go in some different way. Yes. So you can say at least one assumption you can take, which is a valid assumption by seeing the each and individual words of this problem. Assumption. Accidents are independent. That means the accident of car 1, 2, 3, 4, 5, 6, 7, they all are independent. C1, C2, C3 till C7, let's take their event for the car accident, they all are independent. Now, let me discuss about the probability for a car accident to be occurred on a certain day. See, how many days you have? 7 number of days you have. Let's take the accident you have met on Monday. What would be the probability of that? That would be simply 1. Obviously, at any particular day, the accident was met. What would be the probability of that? It would be simply 1 out of 7. Why? Because the accident could have been taken place in either of day, which starts from Monday, goes till Sunday. But if you are picking a certain day, it could be Monday, it could be Tuesday, it could be Wednesday. What would be the probability that the car got accident on that day? Would be simply equals to 1 upon 7. Now, exactly what this problem is seeking for. The 7 car accident occurred in a week. What is the probability that they all occurred on the same day? How? Either they could have been occurred on Monday, all 7, or Tuesday, or Wednesday, or till Sunday. If all of the 7 accident was met on the same day or Monday, still my requirement is satisfied. If all of the 7 accident was taken place on Tuesday, then also my requirement is satisfied. So I can say if all of the 7 accident was taken place either from M or T or W till S, my requirement is getting satisfied. So may I know how all of the 7 accident would take place on Monday itself? That would take place if we talk about the probability of car accident on Monday, C1 and C2 and C3 and intersection C7. May I know how the intersection would be addressed? Until and unless you do not know which kind of relationship these events carry, you cannot use any formula, but you have clearly written C1 till C7, they are independent in nature. So you'll just take the probability of C1 gets multiplied with the probability of C2 and goes till probability of C7. The multiplication would take place. How many times? Here also the same value would come. Here also it would be a P of C1 intersection C2 intersection C3, so on. It will go 7 number of times. So the 7 is going to be multiplied over here. 7 is going to be multiplied over here. And if we talk about the P of C1, it would be 1 upon 7. 1 upon 7, 1 upon 7, how many times? 7 times. So simply it's going to be 1 upon 7 to the power of 7. May I know what would be this probability? It would be the probability that all of 7 has been met with the accident with a fixed day Monday, maybe a fixed day Tuesday. But nobody have said that the fixed day has to be a Monday or Tuesday. They have just said it could be anything on Monday or Tuesday, on Wednesday or till Sunday. Obviously the 7 is going to be multiplied. The answer is going to be 1 divided by 7 to the power of 6. 1 divided by 7 to the power of 6. Yes? Yes? So here it's going to be option number B. For, yes, option number B. Is this part is clear to all of us? If it is clear, you can just write clear, and wherever you guys are having doubt, you can just put it over the comment box, and then we are going to have the next problem. Tell me, till this point each and everything is clear, no? Then we'll move ahead with the next problem. Tell me. Yes. The next problem comes from GATE Civil Engineering year of 2010. The problem was framed by IIT Guwahati. Let's see what the problem indicates. Two coins are simultaneously tossed. The probability of two heads simultaneously appearing is one of the worst problem you can say. Even this sort of problem do not come even in 8th as well as 9th. Straight away you can go ahead with the classical theory. Deliberately I have chosen this problem because you should also have a clear-cut idea how to apply the classical theory over the probability. So first what you do? Focus over your sample space. The two coins are tossed together. The 2 can be the outcome in first, 2 can be the outcome in second. So here the number of outcomes are going to be 2 into 2, no? That's a 4, which could be tell, then tell, then head, then tell, and then head, then head. Yes. May I know what's your favorable event? Let's take E is your favorable event. Where we just had to focus over a situation where both of the faces are found to be head. In future you are going to discuss about P of E, probability of the occurrence of event E. May I know what it would be? The number of element in your set E and number of element in your set of sample space, which we simply write M and N. Now, how do we calculate? How do we count the number of element in a certain set? N of S. How many sets? How many elements we have? 1, 2, 3, and 4. And similarly, it's 1. Here it's going to be 1 divided by 4. 1 divided by 4. Yes. C is the bestmost answer. Deliberately I have taken a softened question. Once you'll go through our previous year GATE book, you will get to know most of the questions which have been keep coming from the probability. They are very lighter and they are very simple in node, but still the questions are going to be related the way the questions have been displayed over the digital board. It's a 1 upon 4. So probably this also must be clear to all of us. Yes, it's a problem where most of the students are going to make mistake. The problem have come in GATE Electronics year of 2014. The problem was framed by IIT KGP. In a housing society, half of the families have a single child per family, while the remaining half have two children per family. The probability that a children picked at random has a sibling is. I know This problem cannot be solved using any of the formula. The common sense and your aptitudinal mind should be used to crack this problem. To crack this problem. Tell me, what would be the answer for this particular problem? Tell me, what would be the particular answer for this problem? In a housing society, half of the families have a single child per family, while the remaining half have 2 children per family. The probability that a child picked at random has a sibling is. Try to decode the each and individual word in the great detail. I know most of us would give the wrong answer for this. Most of us. See, the problem has been designed, or the problem has been picked after watching so many if and buts. I know deliberately I am going to make mistakes on each and individual problem, and that is why this problem is also being picked up with the same merit. I want the answer from each one of you. What would be the answer for this? Tell me. So let me give you 30 seconds. I want the answer from each one of you. Half. What else? This was the problem for the 2 marks. Tell me. I want more replies from you guys, because probably after taking 1 or 2 number of questions, we are going to end today's session. I want the reply from you guys. See, assume in this way, the total number of families you can take, the counting as n. Total number of families. Out of n number of families, half of them falls into the category who have got only 1 child, and half of the family who have got the 2 children. Obviously, 1 child, 2 children. Or this is a category where the individual child, any of the child you can pick, does not have their sibling. Sibling means bhai and ban. Like I have got 2 number of siblings, they are younger than me. So siblings, so definitely if you are picking any of the child from this group, they will not have their siblings. No, they will not have their siblings. And if you pick any of the children from this group, definitely they will have 1 sibling, or they will have sibling. Is that part clear? Now let me tell you, 1 child coming from n by 2 number of families, how many total child is coming from this group? The total child which do not carry any sibling, their counts are n by 2. Yes. And now if we come to this point, remaining n by 2 number of families are having 2 number of children. So may I know how many total number of childs you will have? N by 2 families, each family contains the 2 number of children. Put together, you will have total n number of child. Yes. And now you are interested in getting the probability such that this both of the groups got mixed. Now this group where the n by 2 number of childs are there who do not have any sibling, and similarly n number of childs which is having a sibling, they have been mixed up. So may I know what would be the new size of sample space? The n by 2 plus of n, that would become 3n by 2. So you have a bunch of 3n by 2 number of children, and you are going to pick 1 out of that, and you wanted to have the probability that the picked up or taken out student or taken out children is having a sibling. That means that child has to be picked up from this zone. So it would be m divided by of n. M, the total number of favorable cases. How many there? How many there? N. Out of total number of elements or the size of the sample space. The answer is going to be 2 by 3. 2 by 3. Is that part clear? Is that part clear? Nobody should get confused, sir. We are not able to approach the probability. Deliberately, the each and every problem have got the different varieties as well as different concepts. I have taken the problem in this way. I have taken the problem in this way. So the best most is going to be 2 by 3, and probably the answer of 2 by 3 in NAT would be 0.6 bar or 0.66. 0.66. Is that part clear? Let me go down. Let me go down. Now it comes with the question number 9. No. Once you'll read, Ambika, once you'll read, you'll get to know. He is going to pick out of the children. It has been clearly given, no? It has been clearly given. You did not to worry about it. The each and individual thing has been clearly given in your problem. See, in a housing society, half of the families have a single child per family, while the remaining half have the 2 children per family. The probability that a child picked at the random, see what it is? Probability that a child picked, that means we are not going to have the inclusion of father and mother in our sample space. In our sample space. Is that part clear? Let me go down. The question number 9 it goes. Question number 9 it goes. Tell me, what would be the answer for this particular question? What would be the answer for this particular question? Tell me. A fair coin is tossed independently 4 times. The probability of event, the number of time heads shows up, is more than the number of time tails shows up. You can have the 2 different methods. You can have the 2 different methods. Either you can use method 1 manually. Manually, what you had to do? You had to make the 16 different scenarios. And out of 16 different scenarios, you had to look into the events which satisfies your favorable requirement. What it is? The number of times the head shows up is more than the number of tails. That you can do. That you can do. The 16 number of different combinations you can make. Out of 16 number of combinations, you will have the 3 categories. In few of the categories, number of heads and number of tails are going to be same. In few of the categories, number of heads are going to be more than number of tails. And remaining category, the number of tails are going to be greater than number of heads. Number of heads. Is that part clear? So anyways, this you can do in your home. But now let me focus over the M2. Let me focus over the M2. See, number of heads are greater than number of tails. How it's possible? How it's possible? Let's take number of head is 2 and number of tail by default would become 2. See, if 4 times the coin has been tossed and if you are saying the number of heads are 2, by default the number of tail has to be 2. So definitely 2 and 2 cannot be the possible condition. Even 1 and 3 cannot be the possible condition. So may I know when the head would be greater than tail? What are the situations you'll have? What are the situations you'll have? Either you can have 3 number of head, virtually 1 tail would be there. By default it has to be there. If you are saying I have tossed 4 number of times, out of them the 3 number of times the head have appeared, by default 1 time tail would have come. Tail would have come. Similarly the next one. Similarly the next one. Now you can have another scenario when all of the four coins were head and there was no tail as such. See, I can say 3 head and 1 tail or 4 head 0 tail. This is only the situation when you are going to satisfy your requirement. May I know what is going to be the answer over here? See, only 1 time it will happen that all of the coins are showing the face as head out of the complete number of trial, that's 1 divided by 16. 1 divided by 16. And may I know what would be the probability of P having h is equals to of 3 and t is equals to of 1. You can understand in this way. H, 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 T. H, 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 T. How many ways? You can use the concept of permutation over here if you want. What's gonna be the permutation over here? It's gonna be 4 factorial. But h got repeated 3 times. H got repeated 3 times. Yes. Result would be simply 4. And here, this would be 4 divided by 8. That is why I have said each and everything will have its own relationship when we go into the detailed study of any of the problem. Or manually also you can do it's a first place, second place, third place, fourth place. T can come here, can come here, can come here. How many ways? 4 ways out of 8 ways. Put together. 5 divided by 16. 5 divided by 16. And manually also if you will calculate this, you will get the same answer. Yes. Probably each and everything must be clear to all of us. So almost my time, I am running out of time. We'll take few more problems tomorrow, and anyways, we are going to start with the Bayes theorem from tomorrow onwards. First, we'll talk about the concept of the Bayes theorem in the great detail, and thereafter straight away we'll jump into the 2 or 3 number of problems which are related to the Bayes theorem. And probably Bayes theorem, once the Bayes theorem is getting over, we'll go into the concept of random variable and random distribution. Anyways, we'll meet tomorrow. Till then, tata, bye-bye and take care. Thank you very much.